Module 5, Sampling Methods. Sampling is a process of selecting a group of people, events, behaviors, or other elements with which to conduct a study. A sampling frame is a list of all the population elements from which the sample is drawn. This could be extremely large if the population is national or international. This is a need for everyone in the population to have an equal opportunity for selection as an element. Examples of this are the list of all DSIT students enrolled at the University of Southern Philippines Foundation, or a list of children vaccinated with Dingvaxia. Researchers have adopted a variety of sampling strategies. The simplest is a simple random sample. In such a sample, all population members should be equally likely to be included in the sample. In addition, member elections must be independent of all other member elections. Selecting one member from the population should not increase or decrease the probability of selecting another member. In this sense, a simple random sample is a purely random sample selection. Check out the following example to confirm your understanding of random sampling. How many people are there? What is the sample? Did simple random sampling extract the sample? Are you biased? Example 1. Researchers are interested in examining the experiences of twins who grew up together and twins who grew up apart. She gets a list of twins from the National Twin Registry and selects two subsets of individuals for study. First, she selects everyone in the register whose name starts with Z. She looks at everyone whose surname begins with B. However, because of many names start with B, our researchers decided to include only all other names in the sample. Finally, she emails a survey comparing the characteristics of twins who grew up together with twins who grew up apart. In this example, the population comprises all twins enrolled in the National Twin Registry. Researchers need to generalize only to the twins on this list statistically, not to all twins in the country or the world. However, the National Twin Registry does not represent all twins. The conclusions are limited to the registry, but many issues affect the sampling approach described. For example, if you select only twins whose whose names begin with Z, not everyone has the same chance of being included in the sample. In addition, such procedures run the risk of overexpressing ethnic groups with many names that begin with Z. There are other reasons why selecting only Z can bias the sample. Perhaps such people have above average patience because they are often at the end of the line. The same problem occurs when choosing twins whose surnames begin with B. An additional problem with B is that the everything else procedure does not allow you to select adjacent names in the B part of the list. This defect alone means that simple random sampling was not formed. To do this, a researcher needs to understand the sampling methods used to select the samples. There are two types of sampling methods: the probability sampling method and the non-probability sampling method. Probability sampling implies that each individual from the target population has a known possibility of being included for the example. This includes simple random sampling, systematic sampling, stratified sampling, and cluster sampling. While non-probability sampling is defined as a sampling technique in which the researcher selects samples based on the researcher's subjective judgment as opposed to random selection. It is a less rigid technique. This relies vigorously upon the skill of the researcher. There are a few sorts of probability sampling, which we clarify each rudiments and address their advantages and disadvantages. Below are sampling methods under probability sampling. Simple random sampling. This is viewed as the least demanding strategy for probability sampling. To perform simple random sampling, each of the researchers should guarantee that the population is included in the master list and that subjects are then chosen haphazardly from this list. While simple random sampling makes tests that are exceptionally illustrative of the population, it tends to be tedious and drawn out while making enormous samples. Stratified random sampling. The subjects are assembled into various characterizations like sex, educational attainment, or social status. Based on these attributes, researchers arbitrarily select the final list of subjects from the distinctive characterized classifications to guarantee a balanced sample. This probability sampling method is best used when the research aims to study a particular subgroup within a more significant population. It additionally brings about more exact factual results than simple random sampling. This creates layers within a highly accurate sample when representing the layers with the population, but it can be time-consuming when working with larger samples. Systematic random sampling is regularly contrasted with an arithmetic progression where the distinction between two consecutive numbers is of similar value. For example, Dr. Makugay, a lead researcher, is conducting the impact of the COVID-19 pandemic on 100 public school teachers. In order to do this, he picks an integer less than the total population. This will be the first subject of his research, like say, for example, 3. The subsequent stage is to pick another number, which will be the number of people between subjects. Allow us to say we pick 6 in this example. By doing this, the subjects for our investigation would be patients 4, 10, 16, 22, 28, and so on. This permits specialists to make tests without utilizing an arbitrary number generator. Yet, the results are not precisely as irregular as they would be if a product program were utilized. Systematic random sampling is regularly contrasted with an arithmetic progression where the distinction between two consecutive numbers is of similar value. For example, Dr. Makugay, a lead researcher, is conducting the impact of the COVID-19 pandemic on 100 public school teachers. In order to do this, he picks an integer less than the total population. This will be the first subject of his research, like say, for example, 3. The subsequent stage is to pick another number, which will be the number of people between subjects. Allow us to say we pick 6 in this example. By doing this, the subjects for our investigation would be patients 4, 10, 16, 22, 28, and so on. This permits specialists to make tests without utilizing an arbitrary number generator. Yet, the results are not precisely as irregular as they would be if a product program were utilized. Multi-stage sampling. This includes a mix of at least 2 of the likelihood testing techniques. With further advanced examination, utilizing only one probability sampling method does not guarantee randomization to guarantee trust in outcomes. By joining different likelihood inspecting strategies at different phases of examination activities. Researchers can mitigate, however, much as could reasonably be expected. Below are sampling methods under non-probability sampling. Convenience sampling is characterized as a technique received by researchers to gather statistical surveying information from an advantageously accessible pool of respondents. It is the most generally utilized examining strategy as it is unfathomably expeditious, simple, and efficient. By and large, individuals are promptly receptive to be a piece of the sample. Researchers utilize different testing methods in circumstances where there is a significant population. Much of the time, testing the whole local area is outlandish because they are difficult to reach. Researchers use convenience sampling in circumstances where additional sources of information are excessive for the principal research. There are no rules needed to be a piece of this example. Accordingly, it turns out to be unfathomably rearranged to remember components for this example. All the populace parts are qualified and subject to the researcher's nearness to engage as a sample. The researcher picks individuals only dependent on nearness and does not consider if they address the whole populace. Utilizing this method can notice propensities, conclusions, and perspectives in the most straightforward conceivable way. Purposive sampling is a type of non-probability sampling in which researchers depend on their judgment while picking individuals from the populace to take part in their study. This expects researchers to have earlier information about their study's motivation to appropriately pick and move toward qualified members. Researchers utilize purposive inspecting when they need to get to a specific subset of individuals, as participants are chosen since they fit a specific profile. Quota sampling is a non-probabilistic sampling technique where we partition the study populace into fundamentally unrelated subgroups. These subgroups are chosen concerning explicit known highlights, characteristics, or interests. Individuals in every subgroup are chosen by the scientist or questionnaire who is leading the overview. Snowball sampling is characterized as a non-likelihood testing method in which the examples have attributes that are uncommon to discover. This is a sampling method where existing subjects give references to enroll in tests needed for an exploration study. This includes an essential primary source, choosing other potential information sources that will partake in the exploration considers. This sampling technique can continue endlessly, very much like a snowball expanding in size, until the researcher has sufficient information to examine and draw tangible outcomes that can help an association settle on educated choices.